And Kim Tripp with SQL skills.
I love that.
I know, I did. And
Still vertical.
they're in town teaching their most fabulous, formerly called the MCM class, and now it is SQL Server Immersion event. And so they've decided to come speak with us about, what are you talking about? Essential database maintenance. Woohoo! So, everybody, put your hands together for Paul and Kim!
I'm not sure that we're going to need mics. Can everybody hear us okay? Even in the back?
I can hear us.
Huh?
Okay.
Say again.
Yeah.
Yeah.
We're not listening to you.
All right, I'll go first. Okay. Is it going to click? No?
No. Oh, I think it's thinking.
It's thinking about it.
It's down. Don't forget to hit record.
These are like the best laptops ever.
It is recording.
As Brent would say, you should have a max.
Yeah. Yeah, they crashed like 6 times.
Ah, there we go. It
Okay.
wasn't focused. This is actually pretty interesting because the very first user group I ever did in my entire life was this one in the old location in April 2004, where I gave my first ever presentation about index fragmentation. So if you go back and look in your archives, if you guys go back that far, you'll see my first ever user group presentation. Anyway, my name's Paul. I used to work on the SQL Server team for about 9 years or so. Before that, I worked for DEC for 5 years. For 2000, I wrote things like index defrag, show config, bits of checkdb, bulk load, login and recovery. For 2005, I rewrote all of checkdb and repair. Went on to lead one of the core dev teams in the storage engine. And then after we shipped 2005, I decided to change and be called what's called a program manager. So deciding what gets built to talk to customers rather than actually doing the building itself. I got kind of bored with doing that for a while and decided to leave Microsoft in 2007 and join my lovely wife Kimberly, doing consulting, training, talking to people like you guys. So that's what I do now.
Yeah, we find that we always have to tell people that we're married, and I've told this story many times, and some of you have heard this, but one day at a conference somebody came up to me and said, "He's not very nice to you." And I said, "He's my husband." And they went, "Oh, that makes sense." So we always tell that to everybody that we talk to, just in case we end up kind of bickering or something over statistics or something like that.
So 3 interesting things on this slide. My history is really boring. Email, paul@sqlskills.com. I always say if you've been in a class or a user group or anything of mine, free reign to send me for the rest of my life or yours, whichever comes first. Anything to do with SQL Server, and I will answer your question. I might point you at a white paper or point you at somebody else, but you will get an answer from me. Okay. Second thing is our blogs. Who reads either of our blogs? You have a blog. Yeah. Our blogs, our website, there's no marketing, advertising, any of that kind of crap on our website. Lots and lots of free information. Lots of free information, apart from our classes, of course. And then Twitter. Who's on Twitter?
Oh, right on.
Okay, so lots of people on Twitter. There's a very cool thing on Twitter called #SQLHelp. If you can phrase your question in 140 characters or less, minus #SQLHelp. A whole bunch of people like me and Jen and Sean and Kimberly and Jonathan over there, we watch SQL Help and we'll give you free advice. Okay. 24 hours a day, somebody's watching that. Okay. We actually have a schedule.
Not necessarily us.
Not necessarily us. Yeah. And he's not speaking tonight, but this is Jonathan Kahaya sitting over here. He's an MVP, the youngest MCM in the world, and the newest SQL Skills employee.
Woo-hoo. And my name is Kimberly Tripp. I've been working with SQL Server since 1990, and for about the last 15, 16 years, I've been independent of Microsoft. I used to work for Microsoft as well. In fact, that was when I was down at these offices myself, when I was still a Microsoft University employee back in 1991, I think it was, or 92 maybe, and stayed at the Grand Kempinski and taught at the Microsoft offices that were across the street, which I don't believe is this one. I have no idea where I am or anything. Thank goodness for GPSs. But so I've been doing this for a long time, and I really enjoy the questions. That's probably the most important thing for me. Same thing with Paul. My email is on there, blog on there. But at the very bottom of the intro
My blog's better than hers.
Yeah, we're not that we're competitive in any way, shape, or form. But I definitely don't mind questions. And
Yeah, stick your hand up. And,
have anything.
you're not going to interrupt us at all. Ask questions.
Yeah, he'll interrupt me more than you will. Don't worry.
And we will bounce backwards and forwards, so we're not offending
This is
each
just
other.
how we do it.
Yeah.
But yeah, if you have any questions at all, just let us know. Hey Kim, hey Paul, whatever. And we're going to bounce back and forth. The way that we've written this is essentially as a top 10 list. We know what it's like to be kind of doing this stuff at 7, 8 o'clock at night and everybody's tired. So to keep it kind of interesting, we're not going to go in like really super deep on one topic. We're going to keep it a little bit wider, about 200-300 level, although if you have the questions, we don't mind. But the idea here is to try to cover as much breadth as we can and cover the things that we see as some of the most common problems in terms of system health and maintenance. And so we basically did it as a top 10 list, and we'll bounce back and forth on who gets each one of these. Oh, I thought you wanted data files. Okay, I'll do data files. Sure. All right, so as far as a general, I didn't know I was going to do data files, but that's fine. We kind of bounce back and forth too on topics. But as far as the general structure, a lot of you have seen a slide like this before where a database is broken down into two primary portions, the data portion, the log portion. As far as a couple of things to think about, you can have up to 32,767 files per database. That is not a goal. Okay? It is not a recommendation at all to have tons and tons of files. That can actually significantly impact performance. It's been improved over the years so that you can have dozens of files without really any problem. But we've had test scenarios where we created 15, 20,000 files, and it took 8 minutes just to open the database. And that's no longer the case anymore. It's faster, although I don't really care. I haven't done that many tests on the 2005, 2008, or 2008, I guess, is when they've improved it. But I still don't want you to have that many files. In fact, I generally recommend a fairly small number of files and files that are fairly well optimized. Some of the things that you can do to make those files efficient are things like pre-allocation. And so I've got a few tips and tricks on those data files. As far as the log file, the only point that I want to make on this slide right here is notice that you should have only one. There's a lot of myths and misconceptions out there, and one of the most common for the transaction log is that having multiple log files is beneficial. And I just want to stress that it is not. If you want to have better throughput for the log, you want to do so by dealing with the LUN on which the log is placed. And so we're going to talk more about how to make that log efficient. But as far as the data portion, right, having multiple files can be beneficial, and I'll talk about that in a second. Yeah, Sean?
Mark Souza says that MDF is master data file and NDF is non-master data file.
So MDF historically has meant main data file, and NDFs are non-primary data files. They couldn't go with PDF for primary data file because it was obviously already taken. So I always call it main. I've never heard anyone call it master, but that doesn't necessarily mean anything. They reuse terms all over the place, so why not reuse master again? So yeah, I've never heard that term. So that's interesting. I think of it as main, but technically it's the primary file. I mean, that's literally the name for the first file that's ever allocated to a database. And this is actually kind of important because the first file that's allocated, think about this. You do select star from authors, some table, who cares, right? SQL has to find out where the authors table is. So let's say, just for all intents and purposes, that the table it goes to is called sysobjects, right? Well, here's the question. Where is sysobjects? Right? I mean, so there has to be something at a lower layer that knows where sysobjects is. And that's one of the base system tables that we don't directly have access to. Well, that's at a specific page within the first file that's ever been allocated to a database. In fact, there's a variety of system tables that are at very specific locations in that first primary file. And that's why that file, if that file is ever damaged, your database will be inaccessible. Your database will be down. In fact, your MDF and your LDF are the most critical. If you're ever talking about partial database availability, online piecemeal restore, they are only supported against the non-primary data files. They could be named .mdf, even though they really shouldn't be. But any of the second, third, and fourth files, if they are not in the primary file group, they can be down and unavailable, and your database can still be up and running. So the way I always visualize it, especially if I'm going to be developing and working with a VLDB, is I have the MDF isolated and only for system objects, and then I create secondary non-primary file groups with usually at least 2 or more files per file group for my user-defined data and my non-primary data. And for those files and those file groups where I'm going to put my data, I'm going to do a few things to make sure that it's efficient and effective. So the first thing, probably more than anything that a lot of people don't do, is capacity planning. And if you don't do capacity planning, you're going to basically be sacrificing a lot of performance to auto growth. Now, there are some significant enhancements to the way auto growth works, and especially if you're using instant initialization, which I'm going to talk about in just a second, then auto growth for the data portion might not actually take that long. So some people think, hey, I can start my database out at 2 megs and let it auto grow up to whatever size it needs to be. But that's still a bad idea. Even though SQL Server can allocate very quickly, capacity planning goes a long way for trying to ensure nice, contiguous, clean files that are not only contiguous in terms of SQL Server, but also on disk. And especially if those drives are sharing, right, those LUNs with other files, you don't want to be having all these files auto-growing and interleaving with the other files on disk. So capacity planning is really important, and there's a few things we tend to think about in terms of capacity planning. The first thing I usually do is I do an estimate of my monsters, right? Everybody has, I know some of you guys have hundreds of tables. But I bet those top 10 or 12 tables in some of those databases are almost like 4-letter words in your shop. You know what I mean? You know those tables that drive you mad. You know the tables that give you the most grief. And you often know, even if the database isn't a production database yet, which tables are going to become those monsters, the tables that are going to grow the most quickly over time. Right? So you know, even if you have 500 tables, you have all sorts of state lookup tables, things like that, that are piddly little small tables, right? But you have 6, 8, a dozen monsters. Estimate for the monsters. And in terms of your estimates, you're going to also have to estimate for indexes. I usually estimate at 2 to 3 times my data size. So I come up with some estimates from my data portion, and I take that size for the raw data, and I will often multiply it by 2 or 3 as kind of an initial size. But I'm going to come back to that and say a little more. Yeah?
Since you do have, most databases do have so many lookup tables, basically.
Sure.
Does it make sense to put them onto like a lookup file group?
No. Not really. I mean, the question is, would it make sense to take all of these small lookup tables and maybe create a special file for them? I mean, there are some cases where I will isolate one of my monsters onto a file or file group that might be separate and partitioned, and I might even use different LUNs that might have different RAID basically specs. I might use RAID 10 triple mirroring for my most active portion of the database. And then if I have archive data, I might use RAID 10. And if I have older data that I'm not touching as much, I might use RAID 5. I might even throw some of the older data on RAID 0, knowing that I can still leverage partial database availability if I'm in the Enterprise Edition. So for some monsters, I might isolate those, but it's rare that I would end up creating one specifically for the lookups. But I might have a catch-all for all of the non-monsters. So you can make that argument, sure. It doesn't hurt. I mean, I just wouldn't go crazy. I've seen some customers put an object on a different file for every object, and then they put an index, right, on a new file for every single object and every single index. That was one of the cases where somebody said, yeah, we were told that this would be really beneficial, so we created a file for every table and every index they created. They had like 18,000 files, and you kind of go, okay, this is like a nightmare to manage. And yeah, so the first thing I do is I estimate raw data, right, the base table data here. And the way I do that is I look at how many rows fit on a page. And this is important just to make one quick point on this. If you have row sizes that are 5K, realize that rows under 8K cannot span pages. And as a result, a 5K row really takes 8K. So when you start doing some estimates for data, you actually have to factor a little bit of that in. You can't just say, oh, my rows are 5K, so 100,000 rows is 500 meg or whatever. You can't do that. You actually have to calculate it out based on how it's going to fit on the page and whether or not it's going to have a good page density. So these are a few things to think about. Your lob data, I can't give you any estimate on that. That completely varies based on the type of data you're storing, how many lobs you're going to have. Photos, XML, whatever the case may be. And of course, file stream is external, so you don't have to calculate that in your database's capacity planning. Clearly, you have to make sure you have enough disk space for that. You want to estimate growth, too. Don't think of just how much data you have today or how much data you're expecting in the first week. You want to be thinking out for a couple of years. I mean, I know that our hardware doesn't always last that long, but sometimes it has to last much longer as well. So you want to be a little bit conservative on a lot of these numbers, meaning you want to go overboard on storage, right? You kind of want to say, oh, I think I'm going to have this much data, so let me overestimate a little bit. Indexes, like I said, 2 to 3 times your data. And of course, you might want to even guesstimate 10% for the catch-all, smaller tables and their indexes. I mean, that I would just say use a little bit of common sense, you know, based on how many tables you have. And then the last one is interesting. The last bullet there, space for performance. Right? There are some operations that you will absolutely need to do against those tables on a regular basis to make sure that they stay effective over time. And a lot of those operations require space in and of themselves. So I usually take the single largest table, multiply it by 1.5. That's even a little bit larger than what SQL generally needs for the operations. But then, again, I'm overestimating a little bit. And then I've come up with my initial size. I want to come up with a good growth rate, and we personally always recommend that you leave auto growth on. A lot of people say, oh, auto growth is for people that aren't monitoring their databases. In fact, SCOM said that for years and wouldn't monitor your databases if you had auto growth on, which is effectively a bug, and they have finally fixed it in some of the most recent releases of SCOM. But if your databases have auto growth on, you might not actually be monitoring the space. So that's an important point to mention, right? But we do recommend that you have auto growth on. We want to have a good initial size, a good growth rate, and I really recommend a max size that's not unlimited, so that if it grows without somebody watching, hopefully you've also got alerts to be notified if it's growing faster than you expected. But if you do fill, at least you've still got space on the drives before you're completely dead in the water, right? So I want a few safety catches there. And the transaction log, there's a lot of information on the internet that says the log should always be between X and Y% of the data portion of your database, which is BS. There's really no good way to size the log except through some practical testing and your maintenance of things like the transaction log. The log backups will help keep the log smaller by clearing the inactive portion of the log on the backup. So I actually recommend for most of my customers, they do backups every 1 to 5 minutes of the log. And I'll talk more about that. So, optimizing data files, if I put it all together, defrag the hard drives, make sure that they're nice and clean and freshly formatted. Make sure that you've chosen an effective RAID configuration. I could argue you also want to have an effective block size chosen. The preference in general for the block size when you format is 64K. However, in some data warehouses and larger systems, you might even want to format with larger block sizes and use parameters inside a SQL Server to do larger allocations. So there are other things you can do for kind of the high end, but for most systems, 64K is right. Pre-allocate, as I mentioned, to a reasonable initial size. Don't let auto growth be the thing that grows and sizes your databases. You want to pre-allocate and monitor, make sure that these numbers are right. You want to turn on instant initialization. If you don't know what this is, you need to look it up, like right away, tomorrow. Especially if you're setting up development systems, as Sean mentioned, because if you're restoring to other machines, there's 4 phases of a restore. Right? The first phase is called creation and initialization. And when those files essentially don't exist on the restore, SQL has to go out and ask the operating system to create and initialize the files. And if you go and restore a database that's, 10 gig, 20 gig, those are pretty small. But if you start looking at hundreds of gigabytes or terabytes, it could take hours just for the initialization phase. And instant initialization basically makes it almost instant. I mean, it's not exactly instant, but almost instant file initialization isn't as sexy, right? But so it's almost instant initialization. But it might take 2 or 3 seconds for a terabyte-sized file. Okay? Turn off auto shrink. Oh my gosh. Do I even want to go there? Question, yeah, go ahead.
I wanted to ask a question about the page size and the size of your data, formatting for 8K pages. We are going through a process of implementing the 5010 spec.
I have no idea what that is.
It's medical data.
Okay.
And for instance, provider phone went from 20 characters to 80 characters max. There's just
Let's put every possible type of phone number in a generic, really lame column.
There's really ridiculous requirements.
Yeah.
So we are taking it from chart 20 to chart 80, so we don't take up all that room.
Right.
But when it's allocating for the pages, does it allocate
No.
based on the maximum size or
No.
the actual data size?
No. So in terms of how rows are actually allocated on insert, because ultimately this is the question, if we have a column which is a varchar 80 and we put 20 bytes of space, how much space is it actually taking up? For simplicity, I'm going to say 20. However, there is overhead. So what I'm going to really recommend, is that you have some sample data and you use DMDB index physical stats to actually look at the min, max, and average row size from some actual rows that are inserted, because you'll be able to see the rows including the overhead. And I know for like that one column, yes, you might be talking about 4 bytes, but the issue that you'd also have is that rows have a header, rows have a null block, and that null block is 1 bit per column, so you don't want to have to start doing all the calculations at that level. So the easiest thing to do is to create those new tables with the new schemas, right? Maybe take some of your existing data, because obviously you're going to be porting that over, and in a test environment, port over 10,000 of the rows. Then do a very generic select star from sysdmdb index physical stats, see your min, max, and average in your new structure. And then you'll get some insight. Because if they did change some ints to big ints, for example, those are going to be 8 bytes because they're fixed width. So you want to make sure you really see exactly what the changes are going to do. But that's a great thing. It's not that SQL Server always allocates on insert for max sizes. It allocates on insert based on actual sizes, which has some impacts later, too, as things get updated. But long story short, yeah, you want to look at what the actual sizes are. So
because if you do update with a gigantic, right, it'll push past the row, right?
Well, I'm not sure what you mean by.
Well, if the size
See,
of the
it
column
depends.
expands.
So the question or the comment really is, so does that mean if we do update a varchar column, which was 20, and let's say we update it and we make it 80, what happens? Unfortunately, the answer here is it depends. And it depends on whether or not we're talking about a table which is a heap that does not have a clustered index versus a table which is with a clustered index or a clustered table. If it's a clustered table, we could very much so have a page split.
Right.
If it's a heap, you could have what's called record forwarding and record relocation. But that's all I'm going to say at this point, because we just, in terms of time, we'd be here for like an hour just talking about that. But it is important to realize, as that data changes, there are, wow, you're getting them young now. This is awesome. You're going to be a SQL DBA when you grow up? Yeah, right on. Okay, cool. So, sorry. But the end result is that can start to cost you. And you do need to think about that update cost and that splitting. And that's actually something we'll talk a little bit about. Usually not totally related to updates, but often related to inserts. And no matter what, it's still fragmentation. That's one of our top 10.
Is that true for non-clustered indexes also based on varchars?
Absolutely. You can have splitting in any leaf level.
No, I was talking about the storage.
Storage and splitting are actually the same, whether you're talking about the leaf level of the table, which might be clustered, or you're talking about the leaf level of non-clustered, which is actually almost the same structure but fewer columns. Almost. It's actually a little different. Okay. Yeah, and this is actually the point that we're actually already getting to, which is even though there's a lot of things we can do to make the files more efficient, ultimately the thing that has a larger impact are your table structures, whether or not they're fragmented, if they have splits, and so that's one of the things a little bit lower down in our top 10. There's a bunch of blog posts on this, and you can definitely find a lot of good insight into the storage structures. Paul's got a whole series that he called Inside the Storage Engine, the anatomy of a record, anatomy of a page, the anatomy of an extent. And these are all terms that if you're not really familiar with, like an extent, you can get very familiar with them here, and they'll help you out with storage and understanding, basically.
Yep.
And he goes for the log.
So I like to say that the transaction log and login and recovery is probably the most misunderstood part of SQL Server. You all know that I wrote CheckDB. I used to think that teaching CheckDB was the most fun thing, but now I actually like teaching login and recovery in our classes more, because more people you can see
which is why I don't get to do it
penny
anymore.
drop. I know. I used to do it. So the transaction log. The transaction log is split up internally into a bunch of little sections called virtual log files. That's to allow management of the transaction log to be easier for SQL Server. Now inside the virtual log files, there are variable sized what's called log blocks. They vary in size from 512 bytes to 60K. and inside a log block is log records. Okay? So you could think of a log block of having the same kind of structure as a regular data file page, where you've got a bunch of records, there's a header at the top, and there's a little kind of offset array at the bottom that allows SQL Server to figure out where the particular records are. Right? So every time you do something to a database, it's going to write a log record. Every operation that SQL Server does has to have a log record describing it to some extent. Okay? There are minimally logged operations, which means that only the allocation of pages is actually logged. Okay? Everything else is going to be fully logged, which means that every single page, every single chain generates a log record. There is no such thing as non-logged operations to user databases in SQL Server, whatever you may have heard. Okay? The only time there are non-logged operations is anything to do with what's called the version store, either of the two version stores in tempdb. These are not logged at all. They don't need to be logged because there's no recovery for them. Tempdb never gets crash recovered, it gets thrown away. So there's no need to log what's going on in the version store. So everything you're doing is generating a log record, and every log record describes exactly one change to something in the database. The log records get written out sequentially. Every log record has what's called a log sequence number, which determines its place in the transaction log. Log sequence number is made up of three parts, which is the VLF number, the log block within the VLF, and then the log record number within the log block. That's how crash recovery figures out where to find things. Okay. So when you first create a brand new database, your transaction log is going to be essentially empty. It will have a number of virtual log files inside it. The number of virtual log files depends on the size of the transaction log. So if your transaction log is 0 to 1 megabyte, you'll have 4 VLFs, 1 meg to 64 meg, you'll have 8, 64 and higher, you'll have 16. Okay? The same goes for auto growth. If you grow the log, or it auto grows by a certain size, the number of extra chunks or VLFs that you get is determined by that formula. So you can run into problems if you have a very small auto growth, right, and you're growing lots and lots and lots and lots. You can end up with many hundreds, many thousands of VLFs. And this can cause performance problems for all kinds of operations that have to deal with these VLFs. Think of anything that has to scan the log. A log backup, a checkpoint, transactional replication log reader, whether for replication or whether for change data capture, doing a restore operation running crash recovery, rolling back a transaction. Right? The reason for this is because whenever the log management system needs to find a particular VLF, it doesn't know where it is. So it has to start at the start and look through all the VLFs until it finds the one that has the number it's looking for. Right? This was recently fixed in 2008 and 2008 R2 and in Denali, where they've changed it so that you might not have such a big perf hit. The log management system now keeps track of where the last VLF it saw was when it was doing searches, and it will start from that point when it's looking for another one. So on average, you'll get better performance than you did before. But you can still have really crappy performance if you have too many VLFs. And I'm going to tell you how to get rid of those if you do have them. So we start off with a completely empty transaction log. Okay? All of the VLFs are marked as inactive. Okay? An inactive VLF can be overwritten. One that is marked as active cannot be overwritten and reused. A VLF is termed active if there is one or more log records in the entire portion of that transaction log that is required by SQL Server for some reason. It could be required because it hasn't yet been backed up by a log backup. It could be required because it's part of an active transaction that hasn't yet committed or rolled back. Various other reasons. It could be part of a database mirroring send queue, for instance. If a log record is active, then it cannot be overwritten. So the entire VLF remains active. This becomes a problem if, when we get to the end of the transaction log management system goes and looks at the very first VLF to see if it's inactive, so the log can wrap around, because the log likes to be circular. If that VLF is still active, the log can't wrap around, okay, and it's going to end up growing. So as we carry on writing out log records, eventually we're going to bump up against VLF number 2. We will activate it. We'll carry on writing. We will bump up against number 3. We'll activate it. We're going to start having lots of active VLFs. So what we'd like is that there's some process happening in the background that's going to allow the VLFs to clear or become inactive. So this process is known as clearing or truncating the log. Unfortunately, they're both horrible misnomers because nothing gets cleared and nothing changes size. Right? Clearing or truncating the log means exactly the same thing. It means 0 or more VLFs are marked as inactive. In other words, just because clearing the log occurs doesn't mean it can clear anything. Okay? And all that happens when clearing or truncating deactivates a VLF is a single bit gets flipped in the header of this VLF. Nothing gets zeroed, nothing gets removed, nothing gets overwritten. The VLF is marked as inactive. Right? So what does this? Two operations. In the simple recovery model, the only thing that will do it is a checkpoint. Okay? In bulk logs or full, the only thing that will do it is a log backup. No exceptions. Whatever you've heard to the contrary, no exceptions. A full backup will not clear the log. Okay? You may have seen what looks like a full backup clearing the log, because in 2005 onwards, you can now do concurrent, full or differential, and log backups. Now, usually a log backup will clear the log. But if a differential or full backup is running, that data backup is also going to back up transaction log. So the log can't be cleared, because that would break things. So what happens is, the log backup occurs, it backs up the log, right, but it doesn't do the clearing. The backup management system knows that a log backup has occurred. When the data backup completes, the log will clear in a deferred fashion. So it looks like a full or differential backup has cleared the log, but it didn't. It was a deferred clearing from a log backup, and that is where that misconception came from. Okay. So if you are not allowing checkpoints to occur, or more commonly, if you're not allowing log backups to occur, then your log's never going to clear. And it will grow and grow and grow forever until you run out of space, you get a 9001 error, and it falls over. Okay. Single most common cause of logs filling up. Somebody decides, oh, I'm going to take a full backup of this database. And what that does is it changes the recovery model. So if you go to a brand new database and you say, alter database, set recovery full, that will say, okay, the database is in the full recovery model if you query sys.databases, but it's not. It stays in simple as far as the storage engine is concerned. It stays in what's called the pseudo-simple recovery model, where until you take a full database backup, checkpoints will carry on clearing the log. So is that confusing or what? Okay. So if you're an involuntary DBA and you come along and say, oh, nobody's taken a full backup of this database, you take a full backup of the database and suddenly it's switched into the, you must now take log backups, your log will grow forever recovery model, also known as full. Right? And so nobody takes a log backup, and it grows and grows and grows. And we get emails like, we've got this 10 gig database and 987 gig log. What happened? Right? We actually got one just like that one day.
What happened?
What happened? Yeah. So you have to be doing something to allow the log to clear.
Paul, question.
Yes?
Did I understand correctly? You said that for database in simple recovery mode, all you need to do is checkpoint?
A checkpoint will clear the log. Now remember what I said, that just because a checkpoint occurs and it runs the log clearing doesn't necessarily mean it's going to clear anything. There could be a long-running transaction. So say we have a transaction that started here.
Right.
And more VLS, we make them all active. Okay? We do checkpoints, checkpoints, checkpoints. Nothing's going to happen. Because all the way back to here is being held hostage by this long-running transaction. So it's the kind of, somebody comes in Friday afternoon, does a begin trend, does an update, and goes home for the weekend. The log is going to grow all weekend. Okay? Yeah.
So if I have a database in the full recovery model and I backed it up so it's actually in full recovery model, and I don't do any transaction log backups, why can't the full backups clear the transaction log? Because you're good as of that point anyway. Why
Correct.
Why is
Because-
that mechanism not? Why doesn't it do that?
Because by putting it into the full recovery model, you've said that you want to be able to do log backups. And it won't clear the log. If that's what you want to do, use simple.
Can I add?
Sure.
And just to add to that, one of the things that's really important to realize is that SQL is wanting to make sure that you have a very fully rich recovery set of options, I guess I'll say, so that if you think of that full backup, when that runs, it could actually be backed up, but you could actually have something go wrong with that full. So the idea is that The full backup does not break the continuity of the log chain, and if that backup were to fail, you could go to a prior full and still roll forward with logs as if that full, or differential for that matter, had never occurred. So it's redundancy in the redundancy strategy to not clear the log and allow you other methods of still backing up the log as well as doing a full backup. So it's very much so on purpose, and I hope it never changes, really. I love that feature.
Yeah. So. Is there another hand somewhere? No? Okay. So all these different things that I've already kind of mentioned here could stop the log from being able to clear, even though you're doing things that are allowing the log to clear. So even if you're doing log backups, it could be an open transaction. You could have database mirroring set up. The mirror could be down, so the principal's running exposed. It's going to carry on accepting transactions. The log's going to grow and grow and grow until the mirror comes back online and synchronizes. Okay. Incidentally, if that ever happens to you and your mirror goes down, you want to make sure that you decide whether the mirror is going to be down for a long time and actually break mirroring so that the principal's log can clear. Okay. Now, SQL Server knows fine well why the log can't clear, and you can ask it. So go query log reuse wait desk in sys.databases where name equals my database, and it will tell you log backup, active tran, mirroring, replication. It'll tell you exactly why the log can't clear, and then you go and take some corrective action to allow the log to clear. So what happens if we get right to the end of the log and there's no inactive VLFs right at the start? It's going to auto-grow. Okay? You don't want to have auto-grow turned off for the transaction log, because if you get to this state and the log cannot grow, all of your active transactions will roll back automatically. Okay? You might think, how is it that I could have a transaction that's done an enormous amount of stuff and the log fills up, but it can still roll back? Because rolling back a transaction means going backwards through the chain of log records that were generated on the forward path of the transaction, doing the opposite. And doing the opposite means making another change to the database, which means generating log records. They're called compensation log records. Okay. How can it do that if the log's full? The answer is that for every log record that the log management system generates, it also reserves free space in the transaction log, guaranteeing that every active transaction can roll back without having to grow the log file again. Which is why if you have a log file that's grown to, say, 500 gig, you do a log backup, it might only back up to a 250 gig file, because the rest of it's empty space, just in case long-running transactions roll back. Okay. So your write activity is all going to stop. Your active transactions are going to roll back. So then you're going to have to do something that's going to allow the log to clear. Okay. So if you do a log reuse wait desk and it says active transaction, then you could do dbcc open tran. It will tell you the oldest active transaction. You could then go and kill that transaction, potentially. Okay. There's a script that I have on my blog under the transaction log section, which will actually list all open transactions for a particular database with their query text, who's got them open, and so on and so on. Okay. So you can go and figure out what all the active transactions are, rather than dbcc open tran, kill it. dbcc open tran, kill it. Okay, it's a lot faster. Okay. But basically, go do something and then make it so that that can't happen again. So in terms of log file considerations, Kimberly already hit a bunch of these. You only need one log file. Okay? The only time you're going to have an extra log file is if you run out of space in your transaction log and you don't have space potentially to take a log backup. That's the time when you can add another log file. And what it will do is it will carry on using right up to the end of your first log file and then spill over and use the second one. It will never write in parallel to the transaction log. Once it reaches the end of the second log file, it will wrap around to the start of the first one and carry on using them. It's as if they are virtual log files themselves that it kind of puts together. So in terms of isolation, this is very interesting, and it comes together with data files, log files, tempdb, and so on. How do you lay things out on your I/O subsystem? And of course, the answer is a big fat it depends. Okay, it depends on what your I/O subsystem is. Big fat it depends. Yeah, it depends on what your I/O subsystem is. If you have a single direct attached drive, and you stick everything on that single direct attached drive, your performance is not going to be very good. Okay. You might want to have multiple direct attached drives if that's your only option, and then split things out. Data separate from log, tempdb separate from user databases. You might have a single SSD in your system, which is ultra fast, and you can stick everything on the SSD and performance is just fine. It totally depends what your I/O subsystem is. but it also depends on what you want to be able to do in terms of redundancy and availability. Okay, so this is where Kimberly was saying about picking your RAID level. If you pick, say, RAID 0, you have no protection. You pick RAID 1, you've got better protection. You pick RAID 10, you've got even better protection. The log is the single most important thing. It's more important even than the data files. As long as you have a data backup, and you can back up the tail of the log after a system crash, you can recover up to the point of the crash with no data loss. Okay, so the log should be protected at all costs. So RAID 1 or RAID 10 for a transaction log for sure. So in terms of pre-allocation, how do you size a transaction log? There's no magic formula. What you need to look at is what's the largest transaction that needs to be held in the log. That's the first thing you're going to look at. So what's the size of your biggest ETL transaction, for instance? What's the size of the biggest index rebuild you're going to do, for instance? Then look at, is there any potential for replication, the log reader agent not to run constantly? So you might, if your replication log reader agent is running once an hour, you're going to have to hold an hour's worth of transaction log in the log. If you've got data backup, so you've got a full data backup that takes 12 hours to complete, the log won't be able to clear for 12 hours. So you've got to be able to hold 12 hours worth of log at the time that data backup occurs. That's how you figure out how big your log should be. In terms of instant initialization, the log cannot use it. Right? The log always has to be zero initialized. And this is due to the internals of how crash recovery works. We don't have time to go into that, unfortunately. But instant initialization does not apply to the log, even during a restore. It must be zero initialized. Right? Now, in terms of auto growth and number of VLFs, do I have any more on this? No, okay. So in terms of the number of VLFs, if you find that you've got a massive transaction log, thousands of VLFs, for instance, okay, what you're going to have to do, and I'm going to point at a blog post that tells you how to do this. You're going to have to, A, allow the log to clear, B, shrink the log, one-off rare operation, C, grow the log again, specifically to the size that you want it to be. Okay? You should not be shrinking the transaction log periodically. If you have a job that is every week or every month shrinking the transaction log, you're doing something wrong, or whoever set that up is doing something wrong. Okay? Allow the log to be the size it needs to be, and just leave it there. So the log, blog post that's going to help you with that is this one here. If you go to Google or Bing and you do Kimberly 8 steps, the first thing that comes up is that blog post. And that tells you how to fix a broken transaction log. Okay.
My 8-step program to recovery.
It's our 8-step program to recovery, yeah.
12 steps.
12 steps, yeah. We're better. We do it in 8. If you want to know more about login and recovery and how the transaction log works, and everything I've said has just gone over your head, there's an article out for TechNet magazine in 2009 called Understanding Login and Recovery in SQL Server. That is well worth reading for you.
Yeah, I edited it, so it's okay.
Yeah. Should we talk about your spelling capabilities?
No.
No, that's fine. Who's won the most Scrabble games?
Oh, stop it.
Okay. All right,
I'm
next
30
thing.
games ahead in cribbage, though.
That's true.
Cribbage?
So
Cribbage.
cribbage. So we play cribbage an awful lot, and about 4 years ago, I was saying, oh, man, I keep beating you. So she started a book where we keep track of every single cribbage game we've ever played. And we're like 10 away from 1,000 in the last 4 years.
970 games of cribbage.
And we actually keep track of who's, and she's 33 ahead.
Yeah.
In 4 years.
How many of y'all are disappointed they didn't create a database for it?
We have a database of our DVDs, and I have a database of
I've just
books.
lost respect for you.
Yeah,
They
that's
built it in
we're okay with
Access
that.
and a web app.
Yeah. All right, listen. Next thing, tempdb. So tempdb is SQL Server's dumping ground. There's only one of them for the instance. Okay, that's unlikely to change for at least a few releases if it is going to change at all. All kinds of stuff gets dumped into tempdb. You've seen a lot of the stuff that gets dumped in there from 2005 onwards. Snapshot isolation and the version store makes use of tempdb. So anytime you're actually using snapshot isolation or anything that makes use of it under the covers, online index operations, DML triggers, MARS, multiple active result sets. Who uses multiple active result sets? Another one. You are two of them. Wow. Three
No, I
people.
think he has a question.
You got a question? You use Mars?
You use
wow.
Mars?
You are the third people, second and third people I have ever seen
Third people.
since we shipped 2005 that use Mars.
Maybe 4.
Improved performance dramatically.
In 2008 or into the
2005.
Very cool. Okay. It's very, very underused, but it makes massive use of snapshot isolation in tempdb. Okay. One thing that many people don't realize makes a huge use of tempdb is checkdb. because CheckDB calculates a whole bunch of information about the database as it's going along. It has to store it all in memory. And generally, it will take an awful lot more than your box's memory to store what it needs. So it spills out to tempdb. Okay. It could actually be the largest use of tempdb that you've got. You can figure out how much space CheckDB is going to take in tempdb by doing CheckDB with estimate only, all one word. Okay. Now, the problems you can have with tempdb are contention at the I/O subsystem level and contention for in-memory copies of some what's called allocation bitmaps. Specifically one called a PFS, or page free space page, and another one called an SGAN page, or shared global allocation map. So the problem that occurs is if you have, say, a single data file, and you have many hundreds of concurrent connections creating and dropping little tiny temp tables. The little tiny temp tables are going to need to allocate a single bitmap to track all the allocations for that table, and say a single data page. To do that, there needs to be modifications to these two bitmaps, the SGAN page and the PFS page. There's going to be 2 pages in memory with hundreds of threads trying to acquire exclusive access to them to be able to make changes to them. And you're going to get massive contention. Okay? You're going to see resource contention error messages for this guy is going to be 2:1:3, 2:1:1. Okay? And it's going to slow you down. It makes you serialize, essentially, yeah. Now, in 2005, one of the things that my dev team did is they slightly changed the allocation mechanism for temp tables in 2005. So now there's a cache of temp tables. Okay, it's not a very big cache. It's either 32 or 64. I can't remember which. So what happens is whenever a thread drops a temp table, it doesn't really get dropped. Okay? What happens is all the allocations get ripped away apart from this one bitmap, the one data page, and it remains there allocated. The next time a thread wants a temp table, it goes and looks in the cache. And if there's one there, it pulls it out, changes the column metadata, and hey presto, we have a temp table without having to go and party on those bitmaps. So it reduces the contention a bit. Okay? But just because that's there, you're still going to get contention, okay, for a high enough workload. Yeah?
Is that true for table variables as well as temp tables, or just temp tables?
No, because table variables, the question is it true for temp tables and table variables? Table variables will get stored in memory, and only if they need to will they spill out into tempdb. So it's not quite the same thing. Okay.
They act exactly like a temp table at about 10,000 rows. So they do behave the same way if there's a lot of data in the
when they spill.
Yeah.
Yeah. Okay. So getting rid of tempdb contention. The number one thing is turning on this trace flag 1118. Okay. Now that was put in I can't remember, maybe 7 or 2000, and it's still there in every single release. It still works in exactly the same way in every release. Again, contrary to what you might have read on the internet. And this changes the allocation so that 1 page at a time allocations don't happen. 8 pages at a time allocations happen. And this actually, this slide is incorrect. It actually does it for all databases on your instance. But it really has no practical effect in terms of performance on user databases. So most people say it just affects tempdb. It actually affects every database. Now that's going to change some of the contention, and then you're going to have to create multiple data files. Now in 2000, the mantra was create the same number of data files as you have processor cores. So if you have a server with 2 sockets, each of them is a quad core, you've got 2 times 4 equals 8 processor cores.
I don't care about my laptop, but I realized that I was powering the projector switcher. So if my laptop goes off, the projector goes off.
Oh, that's not good.
So
It's down here. Now in 2005, the mantra changed a bit. If you look at the SQL cat teams and Microsoft's guidance, they will say 1:1 still. Most everybody else says start with 1/4 to 1/2 the number of processor cores. And neither is wrong. The cat team and Microsoft guidance, and the Microsoft guidance comes from the cat team. The cat team guidance comes from the customers that the cat team deals with. And they're fabulous, I love them all. The SQL cat team deals with the very largest customers that are using SQL Server. Those customers are going for the ultimate in scalability. That's where 1:1 comes in, on these big honking machines with, say, 64 or maybe 128 virtual cores. Everybody else, all the way down to mom and pop shops with a single instance up to, through SMBs, up to enterprises that don't have massive systems, don't need to create that many cores. Okay? In fact, you could actually do damage by creating too many data files. You can lead to allocation slowdowns if you have a massive sort operation, for instance, that spills out into tempdb because of the way the allocation algorithms work. So you're kind of damned if you do and damned if you don't, almost. Where's the happy medium? If you're seeing contention issues, okay, try a quarter of the number of processors. If you're still seeing contention issues, move up to a half. Now, this is all a big generalization. Okay, lots of SQL Server guidance are big generalizations. There's always exceptions. I know of at least 2 cases with product support on 64-way machines that they needed to create 128 tempdb data files to alleviate their contention based on their workload. Okay? But now you know why the guidance is 1-to-1 from Microsoft and why the guidance is a quarter to a half from everybody else. Now remember though, this is, what's your problem?
I'm waiting for you, so
okay.
I'm next.
This is not log files. Okay? I've seen customers that have, say, 24 cores, 24 data files, 24 log files. And they've been told by their Microsoft TAM or an MCS consultant, data files and log files. Okay? Or another consultant. Okay? Not the case. Yeah?
Okay. What do I look for to see that I've got contention problems with my tempdb?
The easiest way to look is if you, well, okay, so it's not trivial. You can look at the weight stats that you have for your system. Okay, so if you look at a DMV called sys.dmos weight stats, you will be able to see contention for page latch, okay, weights. And I have a whole blog post on this where you can go and look this stuff up. And then what you're going to have to do is look at another DMV called sys.dmos weighting tasks to see which particular page the tasks are waiting for. And you will be able to see a whole bunch of 2:1:1, 2:1:3, and it's this problem.
Well, that's if it's in the first GAM interval.
Generally, only this only happens in the first one.
But it could happen.
It could. It's too complicated. So, if you go to Google or Bing and do weight stats, Paul Randall, you'll come to a blog post that I wrote at the end of last year called "Weight Stats" or "Please Tell Me Where It Hurts," where I explain about weight stats, a query that you can use to give you a nice ordered view of the weight stats, what all the most common weight stats mean, and how to go about debugging them, and lots more links. Okay. And there's a whole bunch of information about tempdb, okay, especially this one, misconceptions around trace slide 1118. Next. Any questions, though? Any final questions about tempdb?
How about the auto growth settings on tempdb?
Auto growth settings for tempdb, not really anything different from what you'd set for user databases in terms of data files and log files.
You're doing
what?
it right on the recorder.
Hello. There we go. I can't think of anything differently, apart from the fact that be aware that if you're growing the tempdb log by a large autogrowth amount, everything that's using tempdb is going to wait. So you might change that to be a little bit less. Now, be careful about the default autogrowth, because the default autogrowth for any transaction log is 10% from 2005 onwards. And if your log is growing higher and higher and higher in terms of size, you leave it at 10%, that means more and more and more and more autogrowth. And you're having to wait for that zero initialization to take place. Jonathan?
tempdb log and VLF size sort of.
Oh, yeah. Here's an interesting thing. If you have a large tempdb transaction log and you're happy that it's got, say, 100 VLFs, 200 VLFs, if you restart the instance, it will recreate the tempdb log, and it will take the size of the log, right, and divide it by using that formula for 8 VLFs, 16 VLFs, and you'll get massive VLFs. So you need to be careful of that as well. It won't recreate the transaction log, it just kind of redivvies it up, if you will. Jonathan has a great blog post about that. Okay, look for Jonathan and tempdb. Are you ready?
You done yet?
I am done.
All right.
Hey, ask questions. They're
So
more
the most
than you.
important thing we're going to talk
Oh,
about
no, no,
tonight,
no, no, no.
indexes.
That's something you
No.
can
I have a question for Paul.
So, I have days and days and days of content on indexes and how to create them and so forth. But what I tried to do in this section is go through my top 10 list on the things that I do and don't want you to do with indexes, some of which I see happen quite often. So if I can try to prevent those things earlier for a lot of you, that's going to be really important. So probably the first and most important thing is don't just automatically add an index on every column. I see that a lot. I see a lot of people believing the tools. I know the tools come from Microsoft. I know the tools are really helpful in a lot of cases. But just because the tool says this index is missing and this index is missing, or hey, in the show plan there's this big green jumps out at you, you don't have this index. Just because those things are kind of hinting to you that those indexes would be useful, they might very well be, but you want to be careful that you don't fall into the trap of believing everything they say and creating every index they recommend. Because ultimately, you're going to end up with too many, in a lot of cases, very similar indexes. In fact, I've seen it happen all over the place. One query needs an index that has a column in the key and then includes one column. Like let's say the column in the key is C4, and then it says include C6. Then another index says, hey, the column you need in the key is 4, but you need to include C8. And another one that says, oh, we need column C4, and you need to include C12. The long story short with that is you're going to end up with a lot of very similar indexes that might not be able to be deleted in their entirety, but you can often consolidate and create better indexes than the indexes that they're recommending. But simply put, I would take time to slowly and iteratively add the indexes and check after you add an index to make sure it's being used and possibly get rid of indexes that aren't being used, especially over time. Okay? And so there are some things to help you out, and I'll just briefly kind of touch on those. So first and foremost, don't go crazy. Don't add indexes on every column. Make sure you start by having really good, effective base table strategies. And that really means choosing the very first thing that you do is choose your clustered index. Then slowly and iteratively add non-clustered indexes, but do so in such a way that you're not adding 15 indexes or just believing everything that the tools tell you. And I've got a few points here that are going to be a little bit hard to do quickly, but general indexing trends and strategies at the bottom of the slide there. Narrow indexes have very, very, very few uses. If you end up putting an index that's just on a single column, that index is very helpful if you have queries that look up that single column and that single column is very selective. But if that column is not selective or the selectivity varies for different values, then having the index on that single column might not actually be useful for all the different types of queries you might run. So what you'll end up finding, especially if you do look at the tool's recommendations, is that most of the time they're going to recommend wider indexes. Indexes that tend to have 3 or 4 or maybe even more columns. Now, I'm not saying that every one of your indexes should end up having all of the columns in your table. That's not the direction I'm going at all. But what I am saying is that wider indexes have a lot more uses. And often you can drop an index when you've created a wider index. So ultimately when I start doing tuning and trying to make sure that I'm ending up with a reasonable subset of indexes is before I create a new one, I'll check to see if there's an index that I can drop as a result of that. A great example, simple example, if I have an index on last name and then I later create an index on last name, first name in that order, then the index on last name is no longer really useful. I can get rid of it. There's exceptions to the rule depending on how wide you go and the types of queries that we're running that just used last name alone. But for the majority of queries, dropping those left base subsets at a minimum would be a good idea. Okay? So the end result is you'll end up with fewer but wider indexes that actually do more for you and can be used by more queries. But a lot of people don't drop those other indexes. You know, they just have this problem and it says create this index, so they create the index. And then they have another problem and it says create this index and they create that index. And the next thing they know, they end up having 39, 40, 50 indexes on a table. And now we've got other problems as those tables get larger. Because that works for a while. Okay? Now, as far as an effective base table strategy, the very first thing you want to do is choose a good clustered index. The clustered index defines the order for that table, and as a result, there's a lot of things that can be negatively or positively impacted by your choice for the clustering key. So I do have a slide on what I mean by a good clustering key. After I create my clustering key, and I'll come back to what makes it a good clustering key in just one moment, but after I create that good clustering key, I will then create my primary key and my unique keys, because my primary key might not be my clustered. Yes, that's the default, but it doesn't have to be that way. I want to choose my clustering key based on other criteria, very important criteria, and whatever the case may be, if that's not the primary key, that's fine. My primary key can be non-clustered. Then, this is an important one too that a lot of people don't do. I manually add indexes to my foreign keys. That can often help improve join performance. It can also help improve the relationship and the management of the relationship of the primary foreign key. Then, if I'm keeping it simple and I don't know a lot about all the internals of indexes and the best way to index, I will leverage some of the tools like DTA. DTA can actually do a better job than the missing index DMVs or the show plan hint, the green hint. And as a result, DTA can give you better recommendations than anything else can. It doesn't do everything, and it won't always do a great job of everything, but it will do a better job on a lot of things than the missing index DMVs will. So simply put, I might take some of my more common queries, run them through the database tuning advisor essentially, get some insight into what the indexes are that it's recommending, and I might slowly, selectively, iteratively add some of those indexes over time. Then I will continue to do that by understanding my workload better. The queries that are still performing poorly, I might start focusing in on those. So ultimately, it's an iterative process, starting from a good base table. And that base table's clustered index really needs to meet a couple of criteria. The things I tend to look for are things like an identity column or a composite key that's like a date identity together. And the reason why is in the clustering key, I tend to be looking for a few things. I tend to be looking for a clustering key that's unique by definition, not one that SQL Server will have to uniquify. That's actually the term they use. You gotta love when they make up words. And the process of unification can be very expensive, right? When you insert a row that's not unique, SQL has to add a 4-byte integer to uniquify it, and that takes time and overhead. And I know you're all thinking, 4 bytes on only the duplicates, who cares? That doesn't take up much. It actually takes up more than you think, because it actually takes up 8 bytes, because the unifier is part of the variable block, so you've got 2 bytes for the variable block, 2 bytes for the offset. Now you've got 8 bytes. Now, if that has to go into non-clustered indexes, which it does, now you've got 8 bytes for all the non-unique values in all of the non-clustereds, so you're wasting space for no reason. So you want a value that's naturally unique. You want one that is narrow. You notice in all these cases, like identity, even GUID is relatively narrow at 16 bytes. I want my clustering key to be as narrow as possible. I do not like clustered indexes on natural keys. I do not like clustered indexes on these 10-column monsters that uniquely identify our rows. There are some thoughts behind why that might make sense, but it doesn't make sense internally in SQL Server for the way SQL Server deals with non-clusters. So ultimately, I'm making my decision for my clustered index not because of queries, but because of how SQL Server internally structures the data. And if I make a bad decision on my clustered, I'm going to make my non-clustereds inefficient. I was working on a system recently. They actually, literally like a month ago, they had a 2000 system, which was painful to have to go back to. And I know a lot of people have it out there. I just don't do as much anymore on 2000. And I've done so much with DMVs that going back and having to do a bunch of tuning on a 2000 server was just like, wow, tie one hand behind my back and let me see how I do, right? But what I noticed immediately was that they had natural keys for almost all of their tables. And there was one table, one of their biggest tables, that had 3 gig of data and 18 gig of indexes. And why did they have 18 gig of indexes? It wasn't because of the index definitions. It was because internally, SQL Server was tacking on these really wide clustering keys onto all of their non-clustered indexes, making all of their non-clustered 4 or 5 times what they really should have been. If they had had a better clustering key, they would have solved huge numbers of their problems. So how do they fix it now, though? Here's the problem. How do you fix a primary key, which is a natural key, which is clustered? Oof. Right? You got to drop foreign keys. You got to disable non-clusters. You got to get rid of the primary key. You got to then create the new clustering key, create the primary key, re-enable the non-clusters, and recreate the foreign keys. Yeah, It's really easy.
That's it.
You know, and well, when you re-enable the indexes, there's only one way to do it, through a rebuild. So that process actually does the rebuild, but the point is, it's painful to do that. So ultimately, you know, they kind of looked at me like, yeah, we're not going to do that for the 2000 server, and what else can we do? And there weren't a lot of options, to be honest, because the database was just so poorly performing and so poorly designed and so heavy. Like, everything was so inefficient, right? So a good clustering key will go a long way. If you do choose to use a GUID, I would try not to use it as your clustering key. It might be a primary key, but make it non-clustered. And if you do want to use it as far as a primary key and a non-clustered index, that's okay. But if you use it for the clustering key, you want to be very careful that you stay away from almost all GUIDs except potentially new sequential ID, which is actually not a sequential ID, it's a pseudo-sequential ID, but it creates a lot less fragmentation in the table. So it is an option, but I have to admit there's lots of other issues that I don't like about kind of GUID abuse, as I would call it. And I have a really, really interesting blog post that some of you guys might want to read. The blog post title is called Disk-Space is Cheap, right? And then as the very first line in the blog post, it's, that's not the point, in like 18-point font. And I go through what the point really is. And I know people always argue with me, disk space is cheap, what's 4 bytes, 10 bytes per row, who cares? Well, it turns out that if you end up with 8 or 10 non-clustered and let's say 100 million rows, the difference is about 70 gig. 70 gig for the difference between a 4-byte clustering key and a 64-byte clustering key. Like if you went with a wide key, we're talking a difference of 70 gig of disk space. 70 gig of memory, 70 gig in your backup. Right? I mean, it's actually huge as you start to look at the overall cost in bigger tables and the overhead associated with it.
How do you find the indexes that the SQL Server adds those 4 or 8 bytes to? How do you locate them?
So this is actually a great question, and I have the perfect answer for this. How do you find all these kind of internals where SQL Server adds these extra columns to the base indexes? And the answer is, well, you could look at included columns and filters using the UI, but you still won't see the column SQL adds internally. So I wrote code to do it, and I put it on my blog. And I have a section, a category called SP_help index rewrites. And I rewrote SP help index, and you can basically use my version of SP help index. And not only will I show, can you? Yeah. Well, but you can't switch over because of the screens and all that stuff. So can you do it on yours?
No, not on mine.
Oh, all right. It's easy to find, though. If you go to my categories on my blog and you do SP help index rewrites, the very last post actually tells you the steps that you need. There's 2 stored procedures. There's kind of an internal stored procedure that you need in addition to the SP help index caller. But I actually list whether or not the index is enabled or not. I actually list fully delimited names and columns. I do the description just like SP help index does. But then I do the columns as defined by the key, include filters, and then I have 2 extra columns, one that tells you the columns that are in the B tree and the columns that are in the leaf level. Because there's actually different rules for which columns go all the way up the tree. Yeah, but we don't have output and stuff, and I'd have to demo it. So
that's where it is.
But that's where it is. SP help index rewrites as a category, and then you can see that there's 2 parts to the post. Stop it. The SP, he always does this to me. So the scroll up a bit
So
more.
where to find it, go over to Kimberly's blog, and on the left-hand side,
Cry.
SP help index rewrites is the category.
Yeah.
Okay.
But scroll up just so much. Stop. Okay, right there. So SP SQL skills expose calls and index levels. This is kind of the internal code that's needed to generate all the tree structures, which is exactly what you're asking. And then here, SP SQL skills help index. You can rename that on the install. Or you can do what I do, which is I set it up as a keystroke. And that works really, really well. So anyway. Oh, I've got, probably spam. Anyway, okay, so just to sum it all up, the key points that I'm looking for are that it's unique, narrow, static, and ever increasing. Those are really the key things I'm looking for in a clustering key.
There you go.
Oh, it did go. So I went too far. There we go. All right. So in terms of workload analysis, one last step here. In terms of indexes, the first thing I tend to do before I do any, if I'm consulting, for example, before I do any adding of indexes, is I get rid of the dead weight, right? I clean up any indexes that aren't being used. And I often use the DMVs to do that. There's a DMV, DMDB index usage stats, and that can start to give you some insight. Make sure you know what you're looking at, though. Look around on blogs and go to a couple of blogs to read about it and read the books online, okay? So you want to make sure you use that correctly, because if your server got rebooted recently, you might not be looking at good information. So make sure you know what you're looking at, but use that. That can actually be very helpful. Then, if I've gotten rid of the dead weight, then I can make sure that good maintenance is in place, right? Because I need to make sure that those indexes are maintained, and that's one of our other bullets here. So I'm going to skip that for right now. And then the next thing I do after I clean up the dead weight and make sure that the indexes I do use are healthy, then I will add indexes. And there's a few things that I can use if you want to use the DMVs. There's actually some good examples out there. For example, Bart Duncan has a blog post. I usually do a search of Bart Duncan missing. He's fine. But if you do a search for Bart Duncan missing, you can find one of his very simple DMV queries to help you analyze what indexes should be added based on the missing index DMVs. But again, I want you to take all these recommendations with a grain of salt. If you just go and add all their recommendations every day, you could actually be adding indexes that already exist, because there are some funky gotchas with the way these things work, and you can't just trust them, right? What you want to do is look at them, take them with a grain of salt, use them on a test environment, make sure they don't already exist, see what their impact is, and then decide if you really want to bring them into production. And unfortunately, even then, you are still not done, right? Gratuitous build slide for 8 o'clock at night, right? You're still not done. You need to have good information for the optimizer to choose the right indexes. So you need to have good statistics. You need to have data that's not fragmented. So these are more maintenance steps, which are our next bullets. So there are still some more posts. No, I've got stats too. Okay, so there are definitely some good posts out there for indexes, fill factor, all sorts of stuff that you may want to look at. And we're going to post the PDF or whatever with these, and you guys have the recording as well to go back to, because we talk so slow. That'll probably be really helpful. All right, so our next one is statistics, okay? Statistics are, as I just mentioned on the prior slide, like incredibly important for optimization, right? When you guys run a query, think about it for just 1 second. When you run a query that affects one row, that's going to be very different from an optimization perspective than a query that returns millions of rows. So every time you give SQL Server a query, SQL Server has to know how much data is going to be processed before it goes to the data, so that it can pick an optimal plan to get to the data, right? So we have like this chicken and egg issue, right? SQL has to know the data before it goes to the data in order to get there efficiently. That's what stats do. And if the stats aren't right, if they're not accurate, if they're not up to date, then the information the optimizer is basing everything it does on is possibly wrong. Therefore, the plan it comes up with might be wrong as well. So good stats usually means better optimization plans. Questions? Comment? Yeah.
Yeah, I found a very large table today that has a lot of non-clustered indexes but has no clustered index. What effect does that have?
So it's an interesting question. Like, you know, your table is either a heap with no clustered index, or it's a clustered table, a table that has a clustered index. And as a result, the way the non-clustered indexes work is a little different if they're on a heap versus a clustered. Now, simply put, I usually recommend a clustered table over a heap. Right now, you have lots of non-clustered indexes that are pointing to this heap structure. So there's something called the lookup ID that in a clustered table is the clustering key, which is why I'm so picky about a really small clustering key. In a heap, that lookup ID is something called the heap's RID. RID standing for row ID. It's an 8-byte value. I can break it down, but simply put, it's an 8-byte value. And that's what helps us look into that data. I'm not going to say that you're immediately in a bad situation. I would probably argue that I could do better, by probably taking one of those non-clustereds and actually making them the clustered, especially if you have some type of unique, static, narrow, ever-increasing ID as a non-clustered. It might actually be much better off as a clustered. That'll get rid of one of the non-clustereds and give you some options that might work better for that particular non-clustered becoming the clustered. So, but that's a hard one to answer just as a straight, would you be better? Probably. But I wouldn't argue that it's the worst thing ever. I mean, if those non-clustereds are good, and they might be doing a lot of the work for you, okay? It's a great question, man. Hard to give you a quick answer on that. Okay, so those stats that help the optimizer to optimize are very important. And, like I said, they help the optimizer to determine how much data is going to be processed. They effectively determine what we call the usefulness of an index. So every index has statistics. You can actually have statistics in addition to the statistics on indexes. And all of those stats effectively help the cost-based optimizer to come up with an estimate of how much data your query is going to process and therefore help to come up with a plan. The statistics that are on the indexes are the most important because they assess the usefulness of the index. But column-level stats and stats, for example, that are recommended by the DTA, if you end up using the DTA, if the DTA says you want to create this index on this table and you've decided after some testing that you're going to create that index, if DTA also recommended stats, if you create the index on the table where it's recommending the stats, create the stats too. Okay? My general recommendation for DTA is to, if you create the index, always create the stats they recommend in addition to that index, if you create the index. Okay? If you don't create the index, then the stats might not be as useful. Often the stats that they're recommending are ones to better supplement that particular non-clustered indexes and its usefulness, okay? But if I end up testing and going with that index because I've figured out that yes, it is beneficial to me, then I will also create all of the stats associated with that particular table, because these stats can help the effectiveness of the non-clustered index for other types of predicates and so forth. Again, hard to do real quickly, but that's a really strong recommendation, by the way, okay?
But if you create the index, it creates stats for it.
It creates stats based on the left-based combination of the key.
Okay.
The other stats that they're recommending in DTA might actually be secondary columns not in a left-based subset, or subsets that aren't left-based.
So it could be like indexes, stats on the included columns or something like that?
Not the included columns, but the columns of the key. So if I have a key which is last name, first name, middle initial,
okay,
you will have what we call density values for the left-based subsets of that key. So I will know last name, first name, middle initial. But if you end up going with the stats that they recommend, they might also recommend a stat just on first name. Or a stat, middle initial is not going to be very interesting, but a stat on first name could be very interesting, even to use with an index that's actually last name, first name, middle initial. So it's interesting. They might put stats on the secondary columns, or they might put them on some other combination of the key that's not in the left-based sort. Yeah?
If you rebuild an index and you create an index, does it calculate the stats the same way?
So if you create an index, if there's data in the table, then yes, the stats are created at that time. If you create a table and create an index and there's no data, it's going to take some time for those stats to kind of build up and be accurate. Now, if you rebuild an index, then you will get stats updated at the time of the rebuild. And Paul's got a little bit more on the rebuild versus reorg. Okay? So, when are they created? For indexes, they're automatically created. If you go through tools like DTA, they might recommend more. But you can actually create even more stats. In fact, a lot of stats. Look at these numbers down here at the bottom, right? And actually, I don't even have R2 on this, but SQL 2000 supports only 249 total indexes and stats. 2005 supports 2,000 stats per table. 2008 supports 10,000 stats per table, and 2008 R2 supports 30,000 statistics per table. And I know some people are going, really? Would I ever really want that many statistics? Statistics are one of the few things in SQL that you can often have a bunch of these things, and even if they don't get used, they don't actually cost you anything. Now, they might cost you if you do what I call sledgehammer maintenance. Like if you have a maintenance operation that just updates all the stats, doesn't even look at whether or not they're being used or of interest at all, then you're going to pay a penalty because you're going to have all these extra stats. But stats that don't get used won't get updated even by SQL. They'll just kind of sit around hanging out going, I'm invalid. I'm just hanging out, right? And if some query runs that needs them, SQL sees they're invalid and it'll update it as part of that query, okay? Which, for that guy, it's a little bit slower, sure. But then they're now updated and accurate for everybody else. And there is even a way to tell SQL Server to update stats asynchronously. So that guy triggers the update but doesn't wait for it. He uses the old stats. So you have options here, but I usually recommend that people use SP create stats to create statistics for the secondary columns of your table. So you remember my last name, first name, middle initial? I actually proactively, in a lot of cases, especially with databases that are a lot more read intensive, not necessarily read only, I'll do this in OLTP as well. There's a lot of queries against that data. SP create stats I will use so that it adds statistics to the secondary columns of the indexes. That's its behavior. If you say index only, and well, full scan is one of the other options to basically how to do a full scan of the data to generate the stats. I don't think I have a slide on that specifically. I do? Okay. So SP create stats, index only, full scan. I couldn't remember if I put it in this deck. So that's my recommendation on this one. Sorry, I'll leave it on there for a second. But SP create stats, index only, full scan. Now, if the data changes, SQL Server will update the stats. How it works, I'll leave that to the white paper. You can there's a full white paper on stats for 2000, 2005, and 2008. Okay? And it's basically 20%. So when 20% of the data changes, the stats are deemed invalid. They don't get updated, they get invalidated. If somebody needs the stats, SQL Server sees that they're invalid and will update them on usage, not on invalidation. They used to update on invalidation in 7.0, and that's why a lot of people got scared of this and turned it off. Okay? So they are much better. There is a white paper. You can basically just look for the statistics white paper, or on our website, again, no advertising or anything. I could care less if you click. Okay? But on our website, there is a white papers page on the left margin of our main page, and it just lists all the white papers we tend to recommend. So you can find it there for sure. This is how it works, but I'm going to skip that just to keep us a little bit on time here, which we're really nowhere near on time. But anyway, auto-updating stats. In 2005 and 2008, it's pretty much the same. They get invalidated when about 20% of the data is changed, and then they get updated only when needed. Okay? Internally, it happens based on a column modification counter, but you don't care to that level, really. I mean, some of you do, but okay. So there's lots of stuff out here on stats. I did the indexing chapter in the SQL Server internals book. There's a lot of good, technical details there. And actually, all the content that I did for that book is actually on my blog as well. Not the actual text, but all the sample code. So you can actually download that and work through a lot of the samples. That's kind of cool as well.
So we're halfway.
No, actually, we're way better than halfway. But it's always funny because we get to this point and people think...
Oh, cool, we have some books to give away. We're halfway through the list, but we're like 8/10 of the way through the deck, okay?
Yeah.
And I'll speak a little bit faster. So we've got the room till 9, so we'll aim to end at like 10:02, so we can still do questions and stuff like that.
Actually, hold on a second. Microsoft was nice enough to give us another half an hour today. So if you guys want to go a little bit longer, that's fine. But I understand most people try to leave like 8:45-ish, so...
Well, let's try to aim for 10-2, but we'll stick around and answer questions after that.
Sounds good.
Yeah, I mean, that's probably the safest, so you guys can get home and be with your families and lives.
So mine's already here.
Yeah.
So I don't care. Okay.
Oh, isn't that romantic?
All right, let's go. We are the world's most unromantic couple.
So
I'm not feeling very well. Whatever. All right, index fragmentation. Two basic kinds of fragmentation. Logical fragmentation, where the pages at the leaf level of an index are not in the same order as far as the keys are defined as they are in terms of their physical contiguity. Okay, that's the one we all know and hate. The one that people don't know so much about is what's called internal fragmentation or physical fragmentation or page density issues. This is where you have wasted space on your index pages. And this can happen because of the same thing that causes logical fragmentation, page splits. Okay? It can also happen because of poor schema design. Imagine you have a 5,000 byte fixed size row in your table. Every page is 8,192 bytes. You have 8,096 bytes available for row storage. How many 5,000 byte rows can you get per page? One. How much space are you wasting for every page? 3,000 bytes. Okay? Same thing with a 3,000 byte fixed size row. You're wasting 2,000 bytes per page. Page splits. Right? So when random inserts happen in index leaf levels, the pages are already full. The key value says the row must go here. Okay? The page has to split to make space. Okay? If you've got SSDs, okay, many people think SSDs don't care about fragmentation anymore. Logical fragmentation, not quite so much. Okay? You're still having to do more trips up and down the I/O stack to get your pages back in because read ahead can't go quite so well. But if you have your database on an SSD and the majority of your indexes are only 50% full, you're wasting 50% of your extremely expensive SSD. Are you going to be happy with that? No. So you still have to care about fragmentation, even with SSDs. So the simplest and most common form of fragmentation is page splits from indexes that have basically random keys. The most common random key is our friend, the GUID. Okay? All kinds of applications use GUIDs, even some Microsoft applications. Anybody a SharePoint admin?
Yeah,
A few
sorry.
people, I'm sorry. Okay. Microsoft SharePoint uses GUIDs for all of their big tables. So SharePoint database has become a horrible fragmented mess. Okay. And page splits are incredibly expensive. They don't just cause fragmentation, they also take up an enormous amount of transaction log space because everything that happens when a page split occurs has to be logged. Okay. So here's an example. This is MySpace. So when MySpace first took off, it was like one day they had 4 subscribers, the next day they had 3 million. Okay. It was a phenomenon. It was like exponential growth. And they had a table which is they've since changed this, obviously. They had a table which is...
Reminded me to check my Facebook status.
Check your Facebook status, yeah. They had a table which held all of the comments from people's homepages. We all know what MySpace and Facebook and so on are. And the key, the primary key for that table was whose page is it, the member ID. So for instance, we would have a whole bunch of pages with all the comments from Paul's page. We'd have a whole bunch of pages with all the comments from Jen's page. We'd have one page with all of Sean's comments because he wasn't very popular back then. And then we'd have a whole bunch of Kimberly's page. Okay? Whenever anybody went to insert a new comment on somebody's page, it was essentially a random insert into that index. So the pages would split. They were finding that they were getting so much fragmentation because they took off and they didn't code for this scale that the materialization of people's home pages was slowing down because of the fragmentation. So every night they had to do an index rebuild. This was on 2000, I helped them do this. Every night they had to do an index rebuild, and then they grew a bit more. They couldn't change their schema quite yet, and so they found fragmentation was getting worse during the day. They had to do an index defrag in the middle of the day, because they hadn't designed for this. They hadn't thought about what's going to happen to my schema when I start to scale to thousands, tens of thousands, millions of users. Okay, they have, of course, since changed this. Right? But it happens to the best of us. Detecting fragmentation. The easiest way to detect fragmentation is to use the DMV that I wrote for you to do that, index physical status. If you're on 2000, you can still use show config. What you need to look for is which indexes do you actually care about. If you have indexes that have fragmentation, that doesn't necessarily mean that it's going to cause you performance problems. Okay? So you might not want to actually do anything about that. Okay? Also, when you're running the DMV, if you have a whole bunch of indexes where you have lovely cluster keys that doesn't cause fragmentation, don't waste resources by running the DMV against those indexes. Okay? Figure out which indexes you're actually interested in by monitoring fragmentation over a couple of weeks. Design a table that lists all the indexes you're actually interested in and use that to drive your index maintenance. Because if you do select star from index physical stats where fragmentation greater than a certain percentage, it's still going to go and scan and process everything before it figures out which ones to give you back. Okay? You're going to waste a ton of resources, especially if you're a 24/7 shop. You don't want all that extra I/O happening on your system. So once you've figured out that you've got fragmentation, your realistic choices are rebuild or defrag. Of course, don't do anything. There's a third option there, create index with drop existing. What that does is essentially rebuild your index, but you're only going to use that if you want to change something about the index, because you have to specify the entire index definition. So it's a pain. If you want to change the keys, the sort order, the location of the index, the partitioning of the index, you would use create index with drop existing. Otherwise, you choose between rebuild and defrag. Okay? So the choice you're going to make is basically going to depend on the fragmentation level of the index, the number of pages in the index, whether you're able to take the logging hit, for instance, of doing a rebuild or not, how much free space you have. There's trade-offs between all these different things. Most people use the numbers that I made up when I was at Microsoft and put into books online, which is 0 to 10%, don't do anything, 10 to 30, do a defrag, 30% or more, do a rebuild. Okay? And don't do anything unless your index has got more than 1,000, 10,000 probably now pages. Okay? Those are good numbers for you to put into production. But basically a rebuild will build a new index before dropping the old one, so it takes a lot of space. A reorganize or a defrag takes a single 8K page. Reorganize is always online. Rebuild, depending on whether you're an enterprise or not, can be offline or offline with the commensurate locking as well. For a very heavily fragmented index, you're better doing a rebuild. For a lightly fragmented index, you're better doing a reorganize or a defrag. Okay. And I've got blog posts that talk all about this. Oh, interrupted without loss of work. A rebuild, if you interrupt it before it finishes, you lose everything, back to square one. A reorganize, the way I wrote it was it can be interrupted at any point and you don't lose anything. Okay, so it's a nice alternative to rebuild, but it just sometimes doesn't do quite as good a job of removing fragmentation. So again, trade-offs. Okay. Misconceptions about index rebuilds. I'm going to skip this because I have a PDF that some of you will have seen on my blog that has 60 pages worth of hundreds of misconceptions, including like 20 or 30 on index rebuilds. So I'm going to skip this. So, fragmentation, lots of information there. There is a white paper. It's written for 2000. Unfortunately, nobody's updated it yet. But a lot of the concepts about what fragmentation is, whether to rebuild or defrag, still apply and translate to 2005, 2008 onwards.
We should just make Jonathan update it.
We should just make Jonathan update it now. Now that he's our boy. He's been calling us granddad?
No, mom and dad. Mom and dad.
Okay. Detecting corruption. Everything we've said so far is totally meaningless if your data is corrupt and inaccessible. So in SQL Server 2000, there was one error message you would see. It was 823. Read error that offsets some hex thing in this file. Please see your system administrator. And you're sitting there thinking, well, that's me. Now what do I do? So one of the things that we did for 2005, and I always like to joke, this is why it took us 5 years, is we rewrote a whole bunch of these critical system messages. So for instance, with this one, you can read it yourself. It tells you exactly what happened, the page ID, the file, the database. Go look in books online, go run a checkdb. So 823 is split now into two, and I like to call these a hard I/O error and a soft I/O error. So 823 is where SQL Server says to the OS, hey, please read me this data from disk. And the OS, for whatever reason, says no. Okay? Probably with some like -1 error code or something. 824 is where it gives the data back to SQL Server, and SQL Server determines there's a problem with the data. Page checksum failure, for instance, wrong page ID, or something else like that. 825 is really insidious. You will not see an 823 or an 824 in 2005 onwards until SQL Server has retried that failed I/O 4 times. Then you'll actually see an 823 or an 824. If one of those retries succeeds, you don't know about it, apart from an informational sev10 message in the error log saying, hey, I had to use read retry. I hate this. If you think about it, Bob Ward hates this. We fought against it when it came in and we didn't win. What this is really saying is a severity 10 informational message saying, hey, you've got transient corruption problems in your I/O subsystem. Okay? If nothing else, if you take nothing else away from this talk tonight, go back to your jobs and put an agent alert on 825, error number 825, so you know when this transient error occurs. Because the next time it might not be transient.
Impending doom.
Impending doom, I call that a sign of impending doom. I've got a link to a blog post that talks about it. Page checksums. So we introduced this in 2005 as a way of SQL Server being able to detect I/O subsystem-caused corruption. It does not instantly detect corruption. The corruption will not be detected until the page has been read in and SQL Server determines that the page checksum it wrote before giving the page to the I/O subsystem is bad. Okay, so you must read the pages to be able to test the page checksums. So you could do, for instance, a regular backup with checksum. That will test all the page checksums, but that's not good enough. You really need to do a regular checkdb, because a page could have been corrupted in memory and then written out to disk with a correct checksum. The only thing that will find that is checkdb. You cannot avoid running consistency checks. Okay? So it's not error correcting. There's a tiny, tiny overhead in terms of CPU. If you can't afford 1% of CPU, you have other problems already. Okay. So it's read, it's checked whenever the pages are read. CheckDB actually uses the buffer pool to do all its reading. So the pages will be tested for page checksums, even if you do a CheckDB with physical only. Okay. If you're on 2005, it wasn't there for tempdb. If you're on 2008, it is. If you've upgraded, you will need to turn on page checksums. When you turn on page checksums, nothing happens. It's not until a page is read into memory, changed in some way, and then written back out that it gets a page checksum. So just doing a select star, doing a backup, doing a restore, doing a checkdb will not put page checksums on your pages. Okay, there's no tool that will do it, unfortunately, either. CheckDB. Okay. So CheckDB is the only thing that's going to read all the pages in your database no matter what, because that's its job. Its job is to eat corruptions and then carry on and tell you what's wrong. It runs online all the time by default. Okay? If you think you've read something saying that it takes locks, that is wrong. It does not take locks. It always runs online. It is the most expensive thing you can do in SQL Server. It will look like it's causing blocking. It's not. It's causing massive resource contention. It will drive your disk queue lengths to many hundreds quite happily. It will suck down all your CPU. It will suck down all your memory. Right? That's its job. Run as fast as humanly possible. Question?
What would be the, could you get a new checksum by updating every record in a table with its current value?
Correct. You could do that. Update in place, for instance. Yeah. Or index rebuilds, for instance. But that's not going to hit your system tables. It's not going to hit the allocation bitmaps. So it's a real pain that there was no tool. And there still isn't a tool that will do it for you.
Yeah, what's up with that?
No, I haven't found a good way of doing the tool yet with background, with undocumented commands. But that's the only way to do it.
Big jump.
Hmm?
Big jump.
There's no way to do it, that's the thing.
There's no way to do it.
Yep.
It ends up blocking.
There's all kinds of undocumented commands that could do it, but they all have nasty side effects. So I haven't found a way to do it. All right. Consistency checks, FAQ. How often should you run CheckDB? It depends. How long is CheckDB going to take? It depends. How do you consistency check a VLDB? It depends. What does it all mean? It depends. Okay? Next slide. No. CheckDB should be run as often as you are comfortable running it. For my clients, I always like to say at least once a week in some fashion, which gets to the how do you consistency check a very large database. Take a backup, take your backup somewhere else, restore it, run CheckDB there. That offloads your CheckDB workload completely from your prod system. Only if you find a corruption on the restored copy do you have to go back to your prod system and run consistency checks. That is the best way to do it. Okay? But you've got to do it reasonably frequently.
And you've just tested your backup
And you've
as
just
well.
tested your backups too.
That's not a bad idea.
The easiest way to know how long CheckDB is going to take for a backup is to run it. For a database is to run it. Two reasons you want to know how long it takes. Number one, if it starts to take longer, that's a good indication it's found some corruption. Reason number two, if your system crashes and you're running CheckDB to figure out what the corruptions are so you can determine your disaster recovery path. If your boss comes over and says, hey, how long till we know what's wrong? It's far better to say, well, we run CheckDB every week and it takes 4 hours. Rather than, well, boss, it's the first time I've ever tried this, so I've got no idea. You'd be surprised. What does all the output mean? We don't have time to go into that. There's an awful lot of information on my blog, this blog post series, CheckDB from every angle. Lots and lots of information there. Just trying to figure out what's gone wrong. Better to restore or repair. This is an interesting one because there's no right answer to this. It totally depends on your company and your company's SLAs, service level agreements. What's more important, downtime or data loss? What kind of backups do you have? If you've got a multi-terabyte database with a single data file, you've got one big data file, that's all you can restore. That might take hours, maybe even days. It might be better to suck up a little bit of data loss and come online faster. It totally depends what's more important for your company. Right? There's no generalization answer. For a lot more information, there's my blog. I'm going to do the next one. CheckDB from every angle, page checksums, and if you're really interested, if you have insomnia, chapter 11 of the internals book, 87 pages on how the VCC CheckDB works internally. It will send you to sleep.
It is very thick.
It's very thick. All right, next thing. Problem notification. I'm going to run through the end.
Oh.
did something go wrong? There's no point running CheckDB. There's no point having alerts set if nobody is monitoring them. Okay? You would be surprised. You've probably seen this yourself. We go into a client and they've got corruption. Well, when was the last time we ran CheckDB? Well, we run it every week. Okay, when did it start failing? I don't know. We don't monitor that. Okay. What's the point? Okay? So, agent alerts and make sure that somebody's monitoring the output of the jobs. Very quick section. Okay. There are blog posts there on how to create agent alerts if you've never done it, both programmatically and using the tools. No excuses.
Yeah, and it's just true that the sooner you find a problem, the easier it's going to be to solve. So you need to be on top of that.
Absolutely.
Find those check-to-be problems early.
Next thing, taking backups. I'm not going to spend a long time here because Sean is doing a fabulous job, I've heard, of teaching you all about backups. So, recovering using backups. Best way to avoid data loss. As I said, not necessarily the best way to avoid downtime. Depends what backups you have. Okay? Your backups also have to exist and they have to work. Okay? Otherwise, you're going to be running repair and having data loss. So different backup strategies. Imagine that we are a company and we're taking a full backup once a week at midnight on Saturday night, Sunday morning. If we crash at 11:59 p.m. on Saturday, we have this backup. What can we restore? Just this backup. We've lost a week's worth of work. Unless you're running in simple recovery model and you're fine with that, that's not usually very good. So most people are doing fulls and log backups. So if we're doing a full backup once a week and log backup, say, every half an hour, if we crash at 11:59 p.m. on Saturday, we're looking at restoring that full backup. 6 days of 48 log backups per day, 47 log backups to get us to 11:30, and the tail of the log backup to get us to 11:59. Okay? That's basically replaying all of the transactions that occurred in the entire week. So I'll tell you a story because we're almost done. So in 2004, when I came down here to do my first ever user group, I was here to be on site with product support for a program that Microsoft had called Frontline, which was sending senior developers out into the front line to talk to customers, to get a feeling for what's going on the front lines. And I was in product support, and I was helping out what's called the server down queue. Funnily enough, people call in and say, my server's down, help. Okay? So this company called in, it was a small bank from the Midwest, and they called in and said, well, we've got this corruption, what can we do? And we said, well, okay, what backups do you have? And they said, well, we don't really want to go there yet. Okay, so we helped them take a backup of the database, we restored it somewhere else, we ran repair it, deleted a whole bunch of stuff. They said, well, okay, that's not acceptable. So we said, okay, what backups do you have? This was in April 2004. So they said, we have a full backup from January 2004, and we've been taking log backups every half an hour since then. So, of course, we hit the mute button, we all laugh, okay? Professionally compose ourselves again, hit this, oh, that's going to be a bit of a problem. And they said, no, it's better, they're all on tape. Hit the mute button quickly. We all crack up again, takes a little bit longer to compose ourselves, hit the mute button again. Okay, let's go for it then. So we put together a script for the miracle of miracles, every single one restored. They called us Tuesday morning. The restore happened finished on Friday. The entire time we were doing this, the entire bank was offline, down, inaccessible, ATMs not working, not accepting payments, nothing. Okay? They went out of business because of that. Okay? Now it's arguable whether they'd still be in business now given the economy, but they went out of business because of that. Now, they thought they had a great backup strategy. We're in the full recovery model, we've got a full backup, we're doing log backups every half an hour. Sounds great. They did not plan a restore strategy. Never ever plan a backup strategy. Plan a restore strategy. What do you want to be able to restore? And then from that, you figure out what backups you have to be able to take to make yourself able to do that restore. Because if they had added one more thing, differential backups, they might still be in business today. Because the differential backup is basically everything that has occurred since the previous full backup. People call these incrementals. They are not incremental. They are cumulative. Log backups are incremental. Okay? DB2 and Oracle have incremental data backups. We do not. So this backup on Saturday morning is basically everything that's changed in the database since Sunday at the data file level. So if we crash at 11:59 p.m., our restore sequence becomes restore the full backup, restore the most recent differential, Saturdays, and then 47 log backups to get us to 11:30 p.m. plus the tail of the log. This guy short circuits 6 times 48 log backups. Right? So you get a much faster restore. Right? The bank should have had that. They didn't. Lots of information about backups. If you don't know very much about how backups work, there is an article I wrote for 10 Magazine in July of 2009, Understanding SQL Server Backups. In November, there's one saying how to restore from a disaster using backups in 10 Magazine as well. Okay. So, we've covered nearly everything. What could possibly be our number one?
Thank you very much.
The most important thing. The most important thing. The single most important thing when you're doing anything with anything to do with a database, database maintenance, backups, restores, is...
Come on, you knew
testing.
this one.
Okay. How many people here tested their backup strategy, be honest, in the last month? Pretty poor showing. Okay. How many people are going to go and test it? Now that you've seen it. Why, you should. More, come on. How many people don't run CheckDB more often than once a month? Don't run CheckDB more often than once a month.
Wow, everybody
Everybody?
runs CheckDB more than once a month.
Cool. Now, they're all lying now, see?
Yeah.
No, seriously. Testing. There's no point. Yeah.
And then-
There's no point having a disaster recovery plan, for instance, that says how we recover from a disaster if nobody's ever tested it. Right? All your most junior people should have tested it. Who's going to be holding the pager at 2 a.m. on Thanksgiving morning? Not you. Right? Because that's the way the world works. It's going to be the most junior people. You listening, Jonathan?
He's got the pager now. No.
Anyway, test.
Hold on. I had one customer once that they had a backup strategy and they had never tested it, and their log backups were always overwriting the prior log backup. So at the time of a disaster, they had their full, and they had the log that was like this long, but nothing that would get them from here to here, right? So it's really, I mean, we could probably spend the next hour just telling you stories that we've encountered with people that have not tested their strategies. So really incredibly important. It really is. That's why it's our number one. It seems like a lame number one to a certain extent, but it is absolutely the most important.
And that's us. So lots more information you can get from our website. Again, no crappy marketing, advertising, just lots and lots of good
Except
stuff.
for us marketing the stuff we have.
No, but no, we pride ourselves in not having pop-up ads and all that other kind of crap that you see. So we have our white papers page, which is a list of all the cool white papers that we think people should read. Our blogs, tons and tons of information. There's also the prep webcasts for MCM that we recorded. There's webcasts that Kimberly's done if you are not bored with the sound of our voices already.
Yeah, I've done 26 freely downloadable webcasts on MSDN and TechNet, and then so that's about 50 hours of content, and Paul and I have done 40 hours of content with Brent and Bob for the MCM prep. And you might actually find, even if you're not prepping for MCM, quite a few of those videos to be very useful. And you should just check out our website to get the list and what the topics are and check those out. I mean, they're free.
Yep. We're going to stay for questions, but thank you very much for listening, giving up your afternoon, your evening, I guess. We love coming talking to user groups, and it's great to see so many people here. So thank you guys very much.